couple things we're going to do today. I would like to go over, yes, I know the video is up to do the odd answers, but when I last checked, I had like 7 people that watched total since it's been posted. All right. All right. So, my friends, let's get out page 3940. Stone's coming around, or supposed to be coming around, checking off. But what kind of questions do you have for me? I know there might be questions on 1 through 5.
We have questions. Remember our conversation yesterday? We got questions.
5. We got 5. All right. So, my friends, number 5, great question to ask for because, friends, what am I doing on number 5 that goes from prior knowledge, not what yesterday's homework was? Am I taking out a greatest common factor, or am I doing something else?
You're doing something else. Whoever comes in with it done, not doing it as we're showing it, gets the credit. That's what you said yesterday. That is what you said.
No, you said it. Boy.
But that's what he said yesterday.
All right.
That is what he said.
It was. And Stone's giving you the opportunity to finish up if you haven't finished up. So, hey, I love it. So, friends, we are going to distribute the 3x squared to each of these. Okay, remember this was kind of what we quizzed on, right? So, friends, help me out. What is 3x squared times x to the third? 3x to the what? Fifth. Very good. Okay, does everyone feel comfortable with that? All right. Now, what is 3x squared times negative 7x squared? What's 3x squared minus 7x squared? Good. So notice we are adding the exponents, right? And then, what is 3x squared times 10x?
Plus 30x.
30x to the third. Good. And then last one. What is 3x squared times 2? 6x squared. So we did not, on number 1, 3, and 5, we did not factor out a greatest common factor. We just put it back together, right? So that becomes something that we have to be very cautious with, that we are knowing that we're going back and forth, okay? All right, what other questions would work for me to help you with?
Number
8? We didn't have to do 8. It was only odds.
Oh.
Number 9. All right. Number 9. So 5x squared minus 6x. Now, the reason I left the above problem up there is to show how these are different. Notice the green number 5 and the blue number 9. Yes, there's less terms, but notice there's no distributing that I'm doing on number 9. That means I am going to try and take something out. So, friends, can I break 5 down any further? Or is 5 just basically 5 times 1, and that's the only way I can get there by whole numbers? Okay? X squared breaks down to what? X times x. Agree? 6 breaks down to 2 times 3. And then x. All right, so critical thinking here. I have these 2 different things here. What do each of the underlined yellows have in common? X. Nothing else, right? That is what I can factor out. That's all I can factor out. So x comes out front. And then what do I have left here?
5x.
I just have a 5x. What should I not forget to put? A minus sign. And what do I have left here if I factor an x out? 6. 2 times 3, which is 6. This problem is done. Okay. Cool. What else did you see from the odd problems on page 39 and 40 that I could help you with? 17. Okay.
This is still so weird.
Okay, so remind me to do 21 here in a second. So 17. I have 2x to the 5th minus 3x to the 4th plus 5x to the 3rd. Now, my friends, I know some of you want to try and shortcut this. If you could shortcut it and get the same answer as me, good for you. If you're trying to shortcut it and you're getting a different answer from me, I highly encourage you to do it the way I'm showing. Okay, can I break 2 down any further?
No.
No. X to the 5th. How many times am I going to write x now?
5 times. It's just so weird. It's just
Okay. Can a 3 break down any further? How many x's am I going to write? 4 of them. And then the plus. And then, can I break 5 down any further? No, it has to be whole numbers. How many x's?
3.
All right. So take a glance at the board. Do you understand where the green, the red, and the black came from?
Yes.
You okay that the minus and the plus sign stayed in there?
Yes.
Okay. So now we have to look at all of our terms. We have 3 terms sitting there. What do I have in common between these 3 terms?
At least 2 x's.
I have how much?
At least 2 x's, right?
At least 2?
Oh, yeah. Yeah.
Yeah. XXX, XXX, X,
yeah.
X, and X. Now notice I kind of did it out of order because there's no rhyme or reason. As long as XXX comes out, it's going to work. Okay? So XXX comes out front, and I'm left here with 2XX minus 3x plus 5. Okay? We can clean this up a little bit. What's XXX?
I mean, 2x.
X to the 3rd.
X to the 3rd. What's 2XX?
2x is 7.
Good. And then minus 3x is good as is. Plus 5.
Plus 5.
There's our answer.
So weird. I
Okay.
get it, but it's weird.
So I understand. It's weird. It's strange. Now, friends, I get it. Bless you. A lot of people is probably thinking, do I have to do it that way? My friends, I am showing you the most simplistic way to do it that makes so much sense in my mind to do it. And as you progress and start doing it better, you might start seeing patterns to take out. Bless you again. But at this point, I truly feel it's important that you make sure you break it down and you kind of highlight, you circle, whatever, to realize what comes out of all the terms. Jackie said 21 as well?
Yeah.
Okay. Can I move off this one, friends? Good?
Yeah, we're good.
All right. Thanks, Morgan. 14a squared b minus 7ab plus 21a to the 3rd b to the 2nd. All right. Do what?
Can we change it to X and Y maybe?
If you want. I'll keep it like this right now, but we're good. All right, friends, let's take the number 14. What times what gives me 14? Guys? 2 times 7? All right. 2 times 7. A squared. How many A's do I write?
2 A's.
And then just B. Does 7 break down? No. Does 21 break down?
Yeah.
What does 21 break down to? 3 times 7. Good. Shh. How many A's?
3.
A. How many B's?
I mean, 2.
All right. So now I have my 3 terms. What does it appear I have in common? At least one thing.
1A.
I have an A. I have a B. And a 7. So friends, what factors out of this?
7A, or no, 7AB.
7AB. Okay. So what's left here?
2A.
2a. What's left here?
Nothing.
What has to be a placeholder?
Negative.
Negative. What's the placeholder as a number? What's the placeholder as a number?
7. Minus 7.
At what?
Third. Minus 3.
I don't know.
If everything factors out, what has to be left behind? What does every number, no matter what the number, have in common? It's an A.
It's a 1.
In parentheses?
In parentheses, 2A.
Oh, okay.
Something, nothing more. You just.
What if, notice what I put on all of them.
Oh, it's
We don't always see it, we don't put it there. So what has to be left behind here? -1. You see that now?
Yeah.
All right. Then, what do I have left here? How much? That's a 3, isn't it?
Wait.
3.
Oh, 3 and then 8 to the second.
And B.
Yeah. I knew.
Done. So, hey friends, I changed the color of one of them. I made that a -1. So if everything factors out of a term, you have to leave a 1 behind. Okay, it doesn't change it, but if you think about it, if I were to go 7AB times 1, I get 7AB. Okay, so you have to have that placeholder. So I'm going to put a little note, placeholder. It has to be there. It doesn't cancel out that term. It just means that I have a 1 left. All right. What else do we see? We good?
Yeah.
All right. So friends, let's kind of start wrapping our heads around some stuff. So if I have 2x plus 3 and x minus 7, and this is not any notes, this is just we're talking as a class. How do I do this?
2x to the second.
Okay, so I go here, so I get 2x to the second, and then what?
Negative 14x, you put somewhere like that.
So negative 14x, and then?
And then you
3x
3x.
times negatives.
Cool.
Which have your 3x combined with 14x.
Yep, and then minus 21.
So that's
Like terms?
negative 11x minus 21.
There you go. All right, so it's right there. Okay, so that looked different. That looked different than what we were doing last night. So then, what if we had this? What if we had something like this? Does this problem that I have on the right side of the board look like the green one on the left?
Mm-mm.
No, so we're not multiplying. So what are we doing? What we're factoring. We're undoing it. So then this one I look at and say, okay, that's going to break down to 5xx. 10 breaks down to what times what? 2 times 5. X, x, x. 15 breaks down to what? 3 times 5. And then I have x, 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 x. Okay? So I broke it all the way down. Now looking at all three of my terms. Now looking at all three of my terms. Here, here, and here. Okay? What do I have in common between all three terms?
At least 2x.
I have an x and an x. What else?
Oh.
So 2x.
Oh yeah. 2 and a 5. And yeah.
Okay? So what factors out of each? 5x to the second, or 5xx. Okay? What do I have left here if I factor 5xx out of 5xx?
Add
What I have right here?
1.
1. Thank you. What do I have left here? 2x. And what do I have here? 3xx. Okay? So let's clean it up. 5xx is 5x squared. 1 plus 2x plus 3x squared. It's done. So is there a difference between multiplying polynomials and factoring them?
Yes.
Okay. Can I show you what we will be getting to?
Oh, no.
I'm going to show you. Can I show you what we're going to get to?
Oh, no. Oh, no.
This is not going to be on tonight's assignment, but I'm going to show you where we're going to get to.
I'm scared for the future, Mr. Stone.
Okay. So, polynomial, yes? It's a trinomial. It's a quadratic. All those things. I now want to figure out what two binomials that I would multiply together would get me that. Okay? We do not need to know how to do this yet. But this is what we're getting to. I just want to build where we're getting to. So I'm going to show you the exact same routine every time once I start teaching this. Friends, if you trust me and you continue to do my exact same routine, it works the same as long as it's squared and there's three terms. Now, I'm going to warn you, there are, in future courses, they're going to refer to stuff saying, hey, this is the 90-10 rule, the 80-20 rule, guess and check. There's all these different ways. But I have found that there's one way that always makes sense for me, and if you stay consistent and true to it, you can do it. Okay, ready? This is the first step. Multiply those. What do I get?
6x and 7.
Okay? So, all I want is I just want the 6. Okay? That's all I want right now. Okay? Now, we have to think about this. What times what gives me 6? 2 times 3. What else as whole numbers would give me 6? What's the most obvious? 1 times 6. Okay? So do you agree that 2 times 3 and 1 times 6 gets me 6? One of those two methods. So now I need to look at one of those two methods. Which of those two methods add up to 5? Does 2 plus 3 give me 5, or does 1 plus 6 give me 5? 2 plus 3. This is going to give me 5. So you do it this way. You go, okay, 3x squared. Whatever order you want, you're breaking this into 2x and 3x plus 2. Okay, and again, you don't have to know how to do this for today. I'm just showing you advanced. Take a look at that 2x plus 3x. If I combine like terms, does 2x and 3x give me back to 5x? Okay, but now we're taking a 3-term item and making it 4 terms. All right. Take a look right here. Just at those that I've highlighted. What do I have the same between those two? X. Good job. I do not have a 3 in common. I just wanted to highlight it. So I get this. Okay? You with me? You with me so far? All right. This one's a little more challenging. What do I have in common between 3x and 2? Good. What number would I have in common? 1. Give me some love. Bam. 1. Oh my gosh. So I'm doing a 1 here. If I factor a 1 out of 3x, I'm left with just 3x. If I factor a 1 out of 2, I'm left with just 2. Hey friends, do I have something in parentheses that looks the same between the two?
Yes.
And
2x.
3x plus 2. These are the same. What do I have left? What's left behind?
X.
If I were to multiply that together, I would get 3x squared plus 5x plus 2. My friends, I can promise you, this method I'm showing you will work as long as they are factorable. Okay? Hey, Arson, I'll take your phone. No, bring it to me. Put it on that desk. You can pick it up from your dean later today. Thank you. So friends, I can promise you this, and I'm going to tell you this not to frighten you, but I will tell you that factoring trinomials is the hardest concept you're going to learn in this class. But my friends, take a look at what we just did. My friends, take a look at what we just did. This is going to be the same concept over and over and over and over. Okay? It's going to be the same concept, same method that we do every time. I can assure you, you're going to get to other classes and you're like, oh no, why would you do it this way? Because look, if you take a look at this and you flip it upside down and you do a somersault, look, it worked. And you're like, I don't know how the hell to do a somersault. Okay? Friends, I'm telling you, please trust me on this one. But and I want to just give you a slight preview of how it's going to work and what we're going to get to. Okay? No, this is not required for today. So what I would like you to do is I would like you to do page 39 and 40. That was the same as last night. And I want you to do the evens. And I also want you to work on, gotta get to it, PDF. There we go. I also want you to work on page 75 and 76. And I want you to do number 1, 2, 3, 4, 5. Actually, we'll just do 1 through 10. Got it? You have the rest of the period to work on this. Okay? Yes, so it's really only on just page 75, but
Okay, gotcha.
gotcha? Good?